Okay, this is me, Jeff Katz, Whaling City Software. Introduction's over. And I'll start reading, you read and I'll talk. Okay, Intel has a yearly partner conference where they typically do their announcements of the new products. And this year it was May 20th and 21st. And the purpose of this was I just wanted to give you a few minutes of the best of what I got out of it, which I thought was their most relevant, new and improved technologies. And specifically what I wanted to talk about is the new core processors, Vpro and their Optane memory products. And a couple of months ago, I did a presentation on Vpro, and hopefully, some of you guys were there, or hopefully most of you were there. I don't really want to repeat that. And also, I know we've talked about Optane a couple of times in the meetings, so I wanted to touch on that. So I'm just going to try to get through this as quick. I'm going to skip a couple of pieces. So from this screen, let me minimize this so I can see it. What I want to pull out of this screen is that is to talk in terms of, Intel has a lot of different types of processors. The ones we're most familiar with are the ones that, I'm most deeply involved with is the core family, which are the i3, the i5, the i7, the i9, which are the ones we're most used to. And then on top of that is the Xeons, which you find in the workstations and the file servers. They update the core family pretty much yearly. And this year they announced the 10th generation at the conference. And this summer is going to be the 3rd generation of the Xeon family, which they update, less frequently. Now, so what you're catching out of this top paragraph is in the core family, they have 3 series of processors. The U series, which has the lowest power, and that's what they put in most of their commercial notebooks.
Jeff?
Up to 6 cores, typically i5s and i7s. They have an H series, which is in the middle. It's a medium power processor that they use for mobile workstations. And again, in i5, i7, i9, and now Xeon, a Xeon W form factor. And the last one is the S series, which is their highest power. And that's what we've got in our desktops. Okay, so that top paragraph is just what I blew through, where they're talking about the series of processors that they have, the U, the S, and the H. And then right below that, and by the way, what's not in here, which they downplay to a great extent on the commercial side, is the i3. Not that it's not available, not that it's not making it, but for one thing, the i3 doesn't support Vpro. And they've also got, an i5 and an i7 chip that doesn't support Vpro. And they make it, it's in some of their lower end units, but Intel really isn't promoting it much, which doesn't mean that computer manufacturers like, HP and Lenovo doesn't promote it. But, on a commercial platform, Intel doesn't really put much, throw much behind it. So right below that second paragraph is the highlights of what they're calling the improvements in the 10th generation. And that includes an updated GPU, general processing unit, which is, the video side of their chip, which is now on board, that'll push up to 3 UHD resolution 4K displays, dual channel DRAM controller, for direct access to the memory, direct access to their Optane memory, which is their new high-speed memory they've introduced, Wi-Fi 6, which is the new Wi-Fi standard, which will give you up to 1 gigabit per second through Wi-Fi, and also have support for the, for the new 5G. USB-C, which will take you up to a 10 gigabit interface, Thunderbolt 3, which is a 40 gigabit interface, both of which are going to give you And Adam, I know you were railing about this, I don't know, a month or two ago in one of the meetings, um, about, all the different power chargers and docks and everything that's proprietary. What this does in notebooks is it really opens up the universality, whatever, makes for universal power supplies, connections. You're going to see a lot more of that on notebooks because you're going to have a single connection, whether it's USB-C or whether it's Thunderbolt 3, which is going to give you universal docking, universal connection of your displays, and charging over the one cable. So you're really going to see a move with now toward universal power supplies and connections.
Great.
So let me quickly go by this one. And I apologize, this one is locked. I got this from Intel and I couldn't hack out the slides I didn't want. So I've got to, now I wanted to talk about this screen for a moment. This is where they're talking about what they've done with Vpro. And like I said, I did a Vpro presentation a couple of months ago, and I showed you the low-level remote management, and I showed you the multi-layer encryption security. And I'm not really I don't want to go over that to any more detail. But what I want to point out in here that I think is relevant is, you'll notice in the second sentence, they have something called Intel Hardware Shield. And I would ask you to take a moment and read that because that is a piece that I think is particularly relevant. If I'll contrast it, this is a bad analogy, but if you buy a modern car these days, that car is going to have, I don't know, a dozen, 15, 20 computers in it. It's going to have all kinds of subsystems, for each, all kinds of parts of the car. They all communicate with each other. They all have processors. They all have firmware and code and storage. A computer, if you really look at it, is very similar these days, where we think in terms of a computer having a processor and that's the only brain in it, and that's really not the case. I mean, nowadays a modern processor is going to have multiple cores. These new Intel chips, not that some prior ones didn't, they're also going to contain graphical processors that have many cores. And beyond that, every subsystem inside of a computer is more processors, more firmware, more storage. And I'm talking about controllers, I'm talking about disk drives, I'm talking about your communications port, a USB hard disk, a USB thumb drive, a memory stick, has a small processor, it has firmware in it to make the thing work. And the problem is that every one of those processors, every piece of those firmware is a target for hackers to inject malicious code. And I mean, that's happened, that continues to happen, it's known. So I know Adam and I have gone back and forth about, our own views of security and antivirus. But the reason I'm focusing on this hardware shield is that most antivirus, anti-malware that we're used to dealing with is sitting at the operating system level, or at least at the operating system and above it. It's all the code that the computer's running. But in fact, there's a whole nother layer at the hardware level below this that has processors and firmware and storage. And that's what this hardware shield addresses, where in the Intel ecosystem, not only can it look at operating systems and above for malicious code, it can do it at the firmware level and all the memory and all the biases and all the CPUs that sit right below that at the hardware level, that none of the antivirus programs that we work with, have the ability to, that I'm aware of, basically keep an eye on. And I'll get into another slide a little later about that. But to me, that's very much the relevance of Vpro, as we're talking about it now, is this hardware shield. So I'm just going to go a little bit lower. I know I'm rushing, but so here, can you see the screen, guys?
Yes.
Okay. The processors, you can see the various families that they have, where the desktop processors in the 10, now these are all generation processors. These are all Vpro enabled processors. Just having it Vpro in the processor doesn't mean you have it, although it wouldn't make sense to put one in your computer that didn't. But other parts of the computer have to support it for Vpro to be working. In other words, if the Ethernet port that's in your computer doesn't support Vpro, then you can't communicate, even if your chip does. So, I mean, that's why they consider this Vpro, these processors Vpro enabled, but there's more that takes it. But getting back, you can see you have in the desktop from i9 to i5 to i7 to i5, and then your Xeon Ws, you know, different frequencies that they run at, different numbers of cores, different amount of cache, and the different amounts of power that these chips can handle, which is directly related. I mean, power in, power out. The faster these chips run, the more cores that they have, the more they can do, but at the same time, the more power they require to run and the more heat they put out. On a desktop, maybe not as important, but then as we get down into the H series, which is the mobile workstations, and the U series, which are your notebooks, you see these power dropping because they don't want to deplete the battery, they don't want as much heat, but also you see these frequencies dropping because these chips are running slower. So Drew, as we get to the bottom and we look at these frequencies and these power ratings, this is what you were alluding to. But these collectively represent the 10th generation of chips that's available in 3 different series, depending upon you know, what kind of computer you're buying, in the multiple, you know, i5s, i7, i9s. And then this next slide talks about first the advantages of Vpro. And here, when you see this hardware shield, you can just take a moment and read down into the various things that this is going to do for you that a regular software antivirus product or anti-malware or whatever you want to call it isn't going to do. So to me, this is a whole nother layer of security that Vpro brings to the table that I see a lot of relevance for. And then one more slide is, and I'll pause this for a minute. And the relevance here, you know, the Thunderbolt, the USB 3, the Wi-Fi 6, which is going to be up to a gig, and also support your 5G, is, you know, is a big part of 10th gen. So Adam, to answer your question, you know, the relevance here, and also somewhere I'm going back and forth, and I'm not seeing it in this slide, but also for people who are interested in Optane memory, the ability to use Optane memory. Oh, here it is right here, this rapid storage technology. I apologize for that. But the integration of Optane memory into your computer, this is dependent right on that. I'm gonna bail out of this one. So let me share one more screen with you if I can. So as you know, or maybe you don't know, I mean, Intel started in the late 60s. They were a memory company. They got into processors a year or 2 after they invented the first microprocessor. You know, the rest is history. Here we are. And Intel is getting back into the memory business, or has gotten back into the memory business. And what they've basically done, if you understand, you know, the basic architecture of a computer where you get this processor on the top, dynamic RAM, you know, which is volatile memory right below it. That's what the processor talks to. On top of that was traditionally, you know, hard drives or tapes. Now you get another piece in the middle, which is an SSD, which is a solid state hard drive, which is still basically the same technology, but, sped up because it's solid state, not physical. Intel has defined this gap in the middle where they claim or they, believe that there's a place for improvement. They've invented this new type of memory technology they call Optane. A couple of 3 years ago, actually, and they keep advancing it. And to some extent, you could say it's, it's looking for a place to be. And as they move it along, they're trying to find the right places to put it. In general, Optane is a little slower than DRAM and a little bit less costly. And by the same time, it's quite a bit faster and more expensive than the NAND type of solid state memory that you find in SSDs, whether it's tri-state or quad state. I won't get too deep into that now. But basically, so it's sort of an in-between type of memory that they're looking to place somewhere to effectively help speed up computers. Whoops. So what they've done is they've defined and understand that Optane is a category, it's a type of memory, but now they're trying to find places to put it and products to put it in that has relevance. So they've come up with essentially two things. The first is they call Optane persistent memory, which is very similar to RAM, to dynamic RAM, except for one thing, it's not necessarily volatile like dynamic RAM, but it's very fast and directly addressable. But the only way you can put it directly into a computer is for the chips to is for the processor to be able to address it and directly recognize it. So you're dealing with the newest processors to be able to do that. And the second thing they've come up with is what they've called Optane SSD, a solid state drive, which is one of two things. It is either a traditional solid state drive, which would be the 3D NAND type with an Optane cache on top of it, which is going to be faster than most SSD drives as they sit. Or the second thing is an pure Optane cache, which you insert between whatever storage you have and the top tier in your memory tier, basically to be used as cache for whatever storage you have and whatever processor and dynamic memory that you have. And I know I've rushed that, but does that make sense to people?
Yes.
Okay. Yeah. So here when we talk about their Optane persistent memory, you can see, the chart, and basically it's inserted, directly into the architecture of the computer. And basically it can be addressed in one of two ways, and that's what this screen is. It can be addressed in a memory mode, and you can read this, in which case it's volatile, but it's actually acting as additional dynamic RAM. Now, the two things to consider is that, in a core CPU, like the i3, 5, 7, those things top out at 32 gigs of RAM addressable. What makes a Xeon special is a Xeon can have and address, hundreds of gigs of RAM. And that's why you see the Xeons in the server with, hundreds of gigs and many, many cores because of all the processing it's running. Now, if you can have a processor that can directly address an entire second set of addressable memory, and that's what this Optane is, that opens up the door for your core processors, and also, enables the Xeons to either address much more memory directly or address an alternate type of memory that's not quite as fast as DRAM, but quite a bit cheaper. So it allows you these different combinations of memory that you can really hone and fit to the application. Or it can be used in what they call app direct mode, where it's almost DRAM performance, but it's acting like a smart cache. where it learns about the stuff that you're executing, you're retrieving from your storage, and it's a very fast caching layer. And that very quickly is what their Optane persistent memory modes are. This screen I'm going to buzz by, but basically this is when it can be good for you, when it's not so good for you. Now the second thing they're using it for is to become SSDs. And I mean, we all know what the SSD technology is right now. This is in addition to it or to supplant it, depending upon how it's used. The last thing I wanted to mention, and what I started on, is that this stuff is coming into the marketplace right now. Over the next month, these computers, are appearing from all the manufacturers, and you'll have a choice of, on all your computers, whether you're buying 9th or 10th generation. So depending upon whether, and this stuff isn't necessarily that much more expensive, but they might be discounting the 9th gen stuff to move it out. So depending upon what you want, you want to pay attention to which generation CPU and feature set you got. And that's it. That's as fast as I can present it.